Hi folks, this is Moondan Raghavan. Today the session is Machine Learning session 017, Significance of P-value. In case of regression models, the P-value plays a major role. So it's very essential to know about what is P-value and why we are using that P-value in our regression models. Agenda of this video. In order to understand the P-value, we need to know population, sample, inferential statistics, and some concept about null hypothesis. Then after we will see what is p-value as a summary. Then we will see what is the role of p-value in a regression model. At last I will share the references that I have used in our p-value analysis. First one, population, sample, inferential statistics. Population, the data set, the entire list of possible data. For instance, you can take art students across the country. And sample, you can take any particular college art students. So sample is a subset of population. In real time, what happens in order to do the statistics activities, it's not possible to get the entire data set or population data set for our analysis. So in that time, we will take the sample, which is subset of population, so that the analysis output out of the sample will be representing the population. So inferential statistics. So whatever we discussed till now, it will be in a definition format. Inferential statistics takes the data from sample and makes inferences about the large population from which the sample was drawn. You might have remember inference concept. Even our machine learning, initially we saw that inference, which means that you will train the data, you will train the model with the data. After that, the trained model will be used to work on the unseen data, the future data. Basically, it's a test data. So in the same way, whatever you are doing, the statistics analysis with the sample data, that will be inferences about the large population. Because the goal of inferential statistics is to draw the conclusion from a sample and generalize them to a population. We need to have confidence that our sample accurately reflects the population. So here the main terminology comes into picture. If you take a sample data, it should be the perfect subset of population, or in other words, you can tell it statistically significant. What I meant here is the sample should represent the entire population. It should not be like a biased, it should not be like a, let's say, a particular set of values. Because the sample represents the entire population. Let's say, for example, entire population having 5% of sugar or diabetes patients, the sample also should have the same 5 to, or let's say not exactly 5, it can be 4 to 5% of sugar or diabetes patients in that group. So basically what I meant is the sample should represent the same kind of ratio when compared to the population, or almost same. So from this, we found out the population and sample difference and inferential statistics. So here sample should be proper, or it should be reflecting the population. P-value and null hypothesis discussion. So from this, we will understand what is p-value. In general, the p-value tells you that the given sample is a reflection of your total population or not. Whenever you go with p-value analysis or p-value understanding in any of the forums or any of the browsers, you will see this topic, which is nothing but null hypothesis. So in order to understand very easily, just you consider wherever you find null hypothesis, you just replace with the word no correlation. So in our case, the p-value is greater than 0.05. You may ask the question, what is 0.05? It is a significant level. So we are setting one significant level. With that, we will compare our p-value. So you take one input or one independent variable, then you will just calculate the p-value for that independent variable. So if it is greater than 0.05, then null hypothesis is true. So as we discussed earlier, null hypothesis you can consider as a no correlation. So no correlation is true in the sense there is no correlation. It is a true statement. So if it's a no correlation, then you will reject that independent variable because there is no mean to add that independent variable in our regressions. And next one, if p-value is less than 0.05, then null hypothesis is false. That means you now replace with the word no correlation. So no correlation is false statement, in the sense it will become a, let's say it is very significant variable. So that include that independent variable which are statistically significant. So in general understanding, you can consider if p-value is greater than 0.05, you will include that independent variable. If it is less than that, you will, if it is 0.05 greater than that, you will just exclude that or reject that independent variable. And if it is less than that, you will just include that independent variable. So p-value summary. The p-values help determine whether the relationships that you observe in your sample also exist in the larger population. The p-value for each independent variable tests the null hypothesis that variable has no correlation with that dependent variable. So what it means, like your independent variable should have the correlation. Then only it is wise to add that independent variable in our model regression or in our statement. If it is there is no correlation, there is no association between the changes in the independent variable and the shifts in the dependent variable. So for example, it may look funny. Let's say whether the customer or let's say the patient has the diabetes or not. So you may take a number of independent variables, let's say food habit, daily physical activities, or let's say hereditary. In that, if you ask the patient has car or not, or let's say the patient is, let's say, going a different place daily or not. So this is definitely not correlated with our diabetes, right? So that time this input independent variable is not required to be in the equation. And next one, in other words, there is insufficient evidence to conclude that there is effect at the population level. So it replaces the same thing again. So with that very general way, we can understand p-value determines whether that independent variable has to be in or not. In simple words, p-value's importance in regression model. In regression model, we may have multiple independent variables as discussed just now. However, it is wise to add only the independent variables which are statistically significant or more correlated with the dependent variable. So for this use, we use p-value of each independent variable whether to include or not in the regression model. So now we will just exclude the null hypothesis concepts and all here. Just you consider the p-value. If it is greater than 0.05, you reject it. If it is less than that, you include that independent variable. Simple as it is. So these are the references I used to understand the p-value. Basically, you can go statistics by Jim. Actually, he has explained very nicely about the p-value as well as for other areas in the statistics. Next one, a man who asks is a fool for 5 minutes. A man who never asks is a fool for life. So at the time when somebody asks questions, we may feel like he is a fool or he does not know that thing. But after that, he will be knowing that he will be improving himself. But a man who never asks is a fool for life. So if you don't ask the questions, we will not be knowing that at all for entire life. So that's what this quote tells. So with this good thought, I will conclude this video. So thanks all. Thanks for watching. Have a nice day.